All right, so section 2.3. So this section is all about graphs and different bits of information that we can get from a graph. And again, this section is pretty important as far as preparing you for calculus. A lot of the things that we're going to be doing here in this section, you will be doing when you get to calculus, and you'll learn different ways to do it. Primarily, right now, we're looking at graphs, and when you get to calculus, you'll learn ways to look at the function, look at the equation, and get the same information. But it's very important for now that you understand what we were talking about when we say these terms that we're going to be using a lot through this section. Probably a lot of it will be familiar, but maybe some of it will be a little bit new. Even if you've heard of some of this, you probably don't know it or may not remember it as well as you should, which is okay. So hopefully you'll know it by the end of the section. So mostly just going to work through examples, and we'll kind of define words as we go along. So the first example, we have the function t, graph below, gives a temperature between noon and 6 o'clock p.m. And so we're just going to get some information from this. And the first ones that we see, t of 1. So we're just getting the value of t. We're getting the y value when the x is 1. So when the x is 1, we see that the y value is 25. So t of 1 equals 25. T of 3 is 30. And then t of 5, we're going to come to where x is 5 and see what the y value is, and it is 20. So pretty simple. I don't think there's anything that you would not have been able to do before. Next, which is larger, t of 2 or t of 4. So t of 2 looks like it's about the maximum. So we would call that the maximum. We'll talk about this a little bit later. But this is the highest point on the graph, so t of 2 is definitely going to be larger. But as far as what we're talking about there, we're just talking about the y value t of 2 or the y value t of 4. Next, for which values of x is t of x equal to 25? So this is also another way to say this. We could say, when is y equal to 25? What are the x values where y is 25? So 25 would be right here. So we are basically looking at this line where 25. So where does the graph cross that line? So we cross at 1. So x equals 1. And it crosses again at 4. So x equals 4. All right, next, for which values of x is t of x greater than or equal to 25? So where is the graph above this line? And so that would be this part right here. And the equal part is important because we need to include the parts where it's equal to 25. So obviously 1 and 4, and everywhere between 1 and 4. So we will write this with the brackets because we want to include 1 and 4. And it's the interval from 1 to 4, including the endpoints. And the net change in temperature from x equals 1 to x equals 3. So we need to find t of 3 and subtract t of 1 to get the net change. So t of 3 looks like it is 30, which we already found actually. So I guess we did find these. So 30 minus 25 will give us the net change. Oops. 30 minus 25. And that gives us 5 for the net change. All right, so hopefully nothing too complicated or too difficult here. A lot of these things you probably could have done before, but maybe not the greater than. I'm sure you've seen that before, but that's one that doesn't come up quite as much as in algebra, I don't think. All right, so domain and range. Obviously, we've talked about domain and range. You've heard these words before. The domain is a set of all x values for which the function is defined. The range is the corresponding y values. And we're going to see some problems here. In fact, this one that we're going to do now, where the graph is cut off, it's truncated in some way. And so we don't assume that these graphs go on forever, especially they usually are indicated by a little circle, open or closed. Of course, the open circle means that we're not including that point. Closed circle means we are. So let's look at the domain and range. We'll see how to calculate this. So the domain, the way to find the domain when it's not just very simple all real numbers, we're kind of yeah, it's not all real numbers. It's a smaller graph that has a smaller domain. Look to the left. What is the left end point of the graph? And so this would be -2. And then go to the right. The right is 2. Now, where people, so most people will get that. Start with the left, go to the right for the domain. The range, you don't start at the left and go to the right. You start at the bottom and go to the top. And the bottom could be anywhere, horizontally, the bottom could be anywhere, and horizontally, the top could be anywhere. So it's not, we're not moving left to right in any way. So in this case, where is the bottom of the graph? The bottom of the graph, now, remember the range is the y values. So the bottom of the graph is not -2, that's the x value. The bottom of the graph is 0 because that's the y value here is 0. And we are including 0. Then where is the top of the graph? The top of the graph is 2. So whenever you have a graph, the graph does not go on infinitely in either direction. Always start at the left, go to the right to get your domain, start at the bottom and go to the top to get your range. Find the domain and range of f of x equals 3x minus 2. So now this is the only one where you're not going to be given the graph, if I remember right, looking through the homework. So, but obviously, linear functions are pretty easy to graph. So how do we do this where x is between 1 and 4? So most of the time, probably you were taught to graph linear functions by plotting the y-intercept and then moving up or down by the slope. So here, -2 is not going to be in the domain, so we don't even need to plot that point. So the way to do this is find f of 1, find f of 4, and just plot those points and connect them. Because we know it's a straight line, we're only between those 2 points. So if we find those 2 points, we can just connect them and go from there. So f of 1 would be 3 times 1 minus 2. And so that would be 1. And we'll just, approximately, there's 1, 1. Now, open circle, because we do not have the equal part here. Strictly 1 is less than x. Same thing when we plot this point, we'll use an open circle. So 3 times 4 minus 2, that would give us 10. And so 1, 2, 3, 4, and we'll just go somewhere up here. So there's 1, there's 10, there's 1, and there's 4. And then we'll connect those. All right, and then find the domain and range. So the domain is already given to us. We really didn't have to do anything for that. So the domain is 1 to 4. We use parentheses because, again, we're not including the 1 and the 4. And then the range is, bottom would be at y equals 1. The top would be at y equals 10. And we're not including those points. So if it's not equal to on either of these, with linear function especially, it's not going to be equal on the range or the domain. It is possible if you have a quadratic, it is possible that the top of the range or the bottom of the range could be included. But with linear functions, if the endpoints are not included, then neither endpoint of the domain and range will be included. So, okay, so that's enough for this one, and we'll continue in the next video.